everyone. Today, I would like to give you a lesson on the topic median of a triangle, properties median of a triangle. Knowledge of the median of a triangle will be useful in many areas. For example, in physics, to find the center of mass of a triangular plate or object, for calculating the equilibrium and stability of structures. In architecture and construction, medians help determine the support points and equilibrium of triangular structures. Roofs, bridges. In computer graphics, when dividing figures into smaller parts, building 3D models, and finding the centers of figures. A median of a triangle is a line segment that connects the vertex of the triangle to the midpoint of the opposite side. In other words, it's a line drawn from a corner of the triangle to the midpoint of the opposite side. For example, we have a triangle ABC. Let's mark the midpoint of side AC as point D, and we'll connect it to point A, and we'll have a line segment called the median. Note that we must mark these lines, which mean that side AD is equal to DC. Now I want to prove to you that we can find the median of a triangle if we are given all its sides. Let CM equal M as the median of the triangle AB equals C, CB equals A, AC equals B. Let the angle CBE be equal to alpha, then the angle adjacent to it will be equal to 180 minus alpha. Let's take the triangle BMC, use the law of cosines in it, and then let's take the triangle AMC, and in this triangle, we will also use the law of cosines. So what next? Then we must add a squared and b squared, and we will get the corresponding equation. Now we get the following equation, 2m squared equals a squared plus b squared minus c squared divided by 2. And from here, we got the formula for finding the median of a triangle if we are given all its sides. Take a look at the properties of the median. A median divides a triangle into two triangles of equal area. You see a triangle that is divided into two equal triangles, and since they are equal, their areas are also equal. The area of ADC equals area of BDC. Let's prove this property. Well, we have a triangle ABC in which the median AM is drawn. And here I also draw the altitude AH in this triangle, and now I first find the area of the triangle ABM, which is equal to 1/2 times BM times AH, and I find the area of the triangle ACM, which is equal to 1/2 times MC times AH, and we know that BM equals MC, so it follows from this that the areas of these triangles will be equal. The property is proven. Okay, go ahead. The medians of a triangle intersect at one point, and at the point of intersection, they are divided in the ratio 2:1, counting from the vertex. Let's draw a triangle ABC. Draw the three medians, AE, CD, and BF. And based on this property, we can say that CA over OE equals CO over OD equals BO over OF equals 2:1. Let's prove it.
Let the triangle ABC be a given triangle M1 and BM2 its medians intersecting at point M. Let us connect successively the points M1 and M2 and the midpoints of the segments AM and BM. Since M1, M2 is the midline of the triangle ABC, then M1, M2 parallel to AB, so M1, M2 equals 1/2 AB. In the triangle ABM, KF is the midline, KF parallel to AB, that's why KF equals 1/2 AB. Hence, KF equals M1, M2, and KF parallel to M1, M2, therefore the quadrilateral KF M1, M2 is a parallelogram. By the property of the diagonals of parallelogram, FM equals MM2 and KM equals MM1. Therefore, BF equals FM equals MM2 and AK equals KM equals MM1. Therefore, BM over MM2 equals AM over MM1 equals 2 over 1, which was to be proved. Having drawn the third median of CM3, it can be shown similarly that the point of intersection of the medians also divides it in the ratio 2 over 1.
You may also need to know about the median of a right triangle drawn from a right angle, which is equal to half the hypotenuse. That is, if we have CM as median, angle C equals 90 degrees, then CM equals 1/2 times AB. Now we move to our problems. Let's determine the unknown quantities from the given data. For example, given the area of triangle BMC, we need to find the area of triangle ABC. So we recall the main property of the median, and recalling this property, we can say that the area of triangle ABC will be twice the area of triangle BMC. Or such a problem is given point O, point of intersection of medians, segment AO is equal to 6. We need to find OM. So we recall the property of the median, and recalling this property, we can understand that OM will be a half of AO. So to find OM, we just need AO divided by 2, and we get that 6 divided by 2 equals 3. Therefore, the answer is 3. So if you understood everything today, I would give you Mercedes GLC as a gift. If you are worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up. And I wish you to understand it as soon as possible. Bye.